welcome you to my YouTube channel PM. So in today's video we will solve a problem based on numerical problem based on space distance and Poisson ratio and various types of plastic constant. So let's read the problem. A bar of 25 mm diameter is tested in tensor. So diameter is given as 25. D is 25 mm and it is in tension. It is observed that when load is 50 kilonewton, so when suppose load is P, which is 60 into 10 to the power 3 kilonewton means Newton, 10 power 3 Newton is applied. The extension measure over a gauge length of 200 mm, L is 200 mm, then extension is 0.12, increase in length, or delta L is 0.12 mm. Okay, and the contraction in diameter is 0.0045 mm. So delta D is 0.0045 mm. Okay, find Poisson ratio and elastic constant. So Poisson ratio is mu or 1 by m. We can denote it by mu or 1 by m, which is equal to lateral strain divided by linear. So what do you mean by lateral strain and linear strain? Suppose this was the bar we are talking about, which has diameter D and length L. So when we are applying the tensile load P, then bar will get deformed little bit and it will become little longer and diameter will get reduced. So this is the final diameter, suppose D dash, and this is final length L dash. So total difference between L dash and L is delta L, which is increase in length, and difference between the D and D dash is delta D, which is reduction in the contraction in the diameter. So what is lateral strain? Lateral strain is, so load is applied in this direction. Suppose this is x-axis and this is y-axis. So load is applied in x direction. Due to that load, what is the deformation in perpendicular direction or y direction? That is called lateral strain. So lateral strain is delta D by D, change in diameter divided by initial diameter, which is equal to, what is change in diameter? We can say 0.0045 mm divided by initial diameter was 25 mm. Okay, so if we divide it, then we will get 0.00018. This is lateral strain. And linear strain is strain in the direction of the load, which is in x direction, which is equal to delta L by L, change in length divided by original length, which is equal to change in length is, say, 0.12 mm, divided by initial length was 200 mm, which is equal to 0.0006. So what is the Poisson ratio? Mu or 1 by m is equal to lateral strain, which is 0.00018 divided by linear strain, which is 0.006. So if you divide it, you will get 0.3. So this is the value of Poisson ratio. What else we have to calculate? You can read again. Find Poisson ratio. It is done. We have to find the value of elastic constant E, G, and K. What is E? E is Young's modulus of elasticity. Okay. G is, which is also denoted by N. I have denoted here it by N. It is modulus of rigidity, and K is bulk modulus. Okay. So we will find one, and in relation to that we can find others by these formulas. You can have to remember these three formulas, 1, 2, and 3. This is the same formula rewritten in different form. So you can remember these three formulas, and after finding E and Poisson ratio you can find other two. Okay. So what is the Young's modulus of elasticity? What is value of E? E is equal to Young's modulus of elasticity is strain or stress divided by strain. This is Hooke's law, as you know. So from here E will be equal to, stress is equal to P by A, and strain is delta L by L. So from here we will get delta L is equal to PL upon A E, or we have to find E, so we will write in form of E. E is equal to PL divided by A delta L. So here we can put the values. See here, P was 60 kilonewton, so 60 into 10 to the power 3 into L was 200 mm. 200 area was, D was, initial diameter was 25 mm. So pi by 4, 25 to the square. This area into delta L is 0.12. So you can find the value of E from here. So if you will calculate after putting these values, then you will find E is equal to 203718.3 Newton per mm square. This is value of Young's modulus of elasticity. So I hope you will check it from your own calculator. Now we have these formulas with us. And we have calculated Poisson ratio 1 by m or mu is equal to 0.3, and we have E is equal to what is value 203718.3. So if you put the value of E here and 1 by m here, then you can find the value of K, which is bulk modulus. Okay, and if you put the value of 1 by m and E here, then you can find value of n modulus of rigidity. So let's first solve this. E is, from here we can see that E is equal to 2n 1 plus 1 by m. Here 1 by m is Poisson ratio, so E is 203718.3 is equal to 2 into n into 1 plus 1 by m is 0.3. Okay, so from here n is equal to 203718.3 divided by 2 into this is 1.3, which will be equal to 78353.2 Newton per mm square. So this is value of n. Now we have to find the value of K, bulk modulus also. So from first equation you can see E is equal to E. In place of E we will put this value 203,718.3 is equal to 3 into K into 1 minus 2 into 1 by M is 0.3, so into 0.3. K will be equal to 203,718.3 divided by 3 into 1 minus 0.6 is equal to 0.4, so which will be equal to 169,765.25 Newton per mm square. So we have all the values which were asked in the question. So I hope you understand this question. If you have any problem, then you can ask in the comment section. Thanks for watching our video. Please subscribe to our channel.